Hi, this is Mr. Max. This is my second part of 5 of coordinate geometry, and I'm going to do the midpoint of a line segment. Right, so when we are talking basically about midpoint of a line segment, you just have to calculate the average of the coordinates. That means you add your x coordinates and divide the results by 2, and you add your y coordinates and divide the results by 2. So suppose this is point A here, which is x sub 1, y sub 1, and that is point B up there, and you draw a line. So the midpoint of the line is in the middle of that line. Alright, remember the line is not horizontal nor is it vertical. So you cannot just simply go and say, I'm measuring it with a ruler and then the midpoint is whatever. So you have to do this particular thing where you take your midpoint by calculating the two x values, add them up, x sub 1 plus x sub 2, divide by 2, and you also do the same for your y. You add your 2, y sub 1 plus y sub 2, and then you divide that by 2. So the midpoint of a line, and you're gonna get the simple, straightforward equation or formula, if you want to say that, of x sub 1 plus x sub 2 over 2 and y sub 1 plus y sub 2 over 2, and this is how you find the midpoint of a line segment. Okay, suppose you know what the endpoints are. Right. So I'm going to do here a few questions that requires you to find the midpoint of the line segment. So I'm going to do them simultaneously at the same time. Okay, you could also pause and do it on your own, and then you see whether you get to the same answer. Ordinarily, it should be very easy. 1 plus 8, which is your x values, and 4 plus 6. And here you do the same. 4 plus negative 5, you must be careful, that becomes a minus, and 7 plus 9. Find the averages, and 11, negative 11 plus negative 3, and 1 plus negative 8. So be very careful with the sign. I would ask you to put brackets there so you do not end up making a mistake. Okay, so this is where we are after you clean that numerator. First answer is 4.5, 5. The next one is negative 0.5, 8, and the other one should be negative 7, negative 3.5. Right, so let's bring in a question. They are saying that x and y are points on the coordinate plane. Find the lengths of the line segments OX, OY. So OX means from the origin, OY from the origin, and XY. So O is the origin. So if I bring in a diagram just to show to you where O, X would be, it's going to be 1, 3. It's that point up there. Right, and O to X is that line starting from the origin. The same applies where Y, the point Y is 2, 6, and if you draw that line from the origin, it's the line OY. You can already see from my diagram here that these points are on the same line. Okay, so when we have to find OX using Pythagoras, as we know, right, 3.142, the square root of 10, using the same formula to calculate OY, you get 2 times the square root of 10, and you also use XY, you get the square root of 10. So this tells us that the X, point X, same distance from O to Y, and it therefore must be the midpoint of the line OY. Let me bring in another question here, question 3. You are supposed to show that the points J, K, and L are vertices of an isosceles triangle. So for us to show that, we have to find the line segments JK, KL, and JL. Okay, so when you do JK, you get the square root of 36, which is 6. When you do KL, using the formula to find the line segment. So look at the first video if you have not gone through how to find line segments. Alright, and JL in its line segment is exactly the same as KL, meaning then you are dealing with an isosceles triangle. So if I bring in a sketch and if I bring in my vertices or my points that I have for my vertices, alright, I know this has to be an isosceles triangle because you have got the distance from K to L is the same as the distance from J to L. Good. So then you are also supposed to find the area of the triangle. Now here, to find the area of the triangle, you have to take half times the base being the square root of 36, being 6. The problem is we need to find a height there, so we need to bring in a midpoint. And when we bring in a midpoint there, in order for us to calculate, first we have to calculate the midpoint. And we use the midpoint formula, and we realize when we do that, we take the points J and K, -1 plus 5, and then 2 plus 2. The average of those gives you 2,2. Right, so, and I can draw the line in now, line L to M. So if I can find that distance there, which is actually 3, okay, don't need to show the LM using this particular method. You can actually see from your, yes, you can see from your, it's a vertical line. So if you take your Y values and you take the differences between 5 minus 2, you get 3. Okay, it's a vertical line. So it's very possible for you to see the length of that line. Otherwise, if you want to bring in LM, you still get, using the formula for the length of a line segment, you'll get that. So now we know our height is 3, we know our base is 6, so we can therefore now calculate the area by saying half times 3 times 6, which is 9 square units. Right, so the last question here is very similar to that. So you've got point R and S and T. You're supposed to find the perimeter as well as the area. So we do the same. We find RS, ST, and RT. So when you find R2S, remember you take your X value of R and the X value of S. Okay, you subtract them, square that, plus the Y value of R, which is this -2 here, minus the Y value of T, which is of S, which is -2. Well, all in all, you should get 12, and you do the same for S to T, you get 10. You do the same for RT, you get 10. You can already see that two sides are equal. Okay, so the perimeter then is going to be just the sum of that. That gives you 32 units. Right, so if I bring my sketch and I bring in my coordinates, my points, so that you can see, all right, so we are dealing with something similar like the previous question that I have done. So I'm going to bring in again the midpoint, and we're going to find the midpoint, all right, by using RS. So the midpoint is going to be -4 plus 8 and -2 plus -2. Well, the midpoint is 2, -2, and again you can see what the vertical distance TM will be. It will be 8. That comes from 6 minus -2. All right, because that is a horizontal line, a vertical line rather. So it's very possible for us to determine the length of this line by taking 8 at the 6 minus -2. Okay, so this is this -2 here and our 6 there. So we will realize we're going to get an 8, and we know what the base is. All right, the base is the longer side here, which is 12. So we can therefore find the area of the formula, okay, by simply using our half times base times height. We know what our height is, but you can also calculate it, obviously. All right, I already showed you that it's equal to 8, but you can calculate it using obviously your line segment TM. Now that you have that, 12 times 8, half of that, gives you the area of this triangle, which is 48 units squared, or square units. All right, so the third video on the series on coordinate geometry that I'm going to do is going to look at the gradient or the slope of a line segment. Okay, so make sure that you don't miss that one out. Okay.